welcome to my YouTube channel. Today we are going to be looking at IUPAC Nomenclature of Alkanes. Please, if it's your first time, go back to our previous class where we discussed the naming of organic compound. It's the foundation for this class. If it's your first time, do not forget to subscribe. Now, before we proceed to the IUPAC Nomenclature of Alkanes, I want us to study the concept of the alkyl group. An alkyl group simply is a group derived by what? Losing a hydrogen ion from the corresponding alkane. When the corresponding alkane loses a hydrogen ion, it becomes what? An alkyl group. For example, so if you remove one hydrogen from an alkane, you have what? An alkyl. For example, your methane, CH4 minus one hydrogen will become CH3. So this is what? Methane. This is what? Methyl. Ethane, C2H6. This is ethane. If it loses one hydrogen, it becomes C2H5. This is ethyl. Then you have your propane, C3H8. If it loses one hydrogen, it becomes C3H7. So this is propane, and this is what? Propyl. So when an alkane loses a hydrogen atom, it becomes what? An alkyl group. Now another group we'll look at is the alkyl halides. So you treat this as substituents, as an alkyl group. So call this in an organic compound, when attached to alcohol, you call it a fluoro. Chlorine is a chloro, bromine, bromo, iodine, iodine. Now, I want us to see skeletal representation because it is what I'm going to be using in this study. I'll be using skeletal representation in the study of IUPAC Nomenclature of Alkanes just for simplicity. So, for instance, your methane has two carbon, H3, H3. Skeletally, I'll represent it as what? CC. I'll remove all the hydrogen. Propane. This is propane. Skeletally, I'll represent it as 1, 2, 3. And maybe if we have a compound like this, H3C, HC, H3, CH3. Skeletally, I'll represent it as this, so that we can do a whole lot and the work will not look clumsy. I hope you understand now. Alright, so let's continue. Now, having understood the skeletal representation, we're going to use 5 tricks that will make it simple for you to understand IUPAC nomenclature of alkane. Once you understand these alkynes and the alkenes will not be a problem. Now, trick number 1, which is rule number 1, you have to identify your parent chain, and the parent chain is simply the longest chain. For example, if I have this like this with this, over here will not be a good place. We have 1, 2, 3, 4, 5. This is one chain. 1, 2, 3, 4. This is another chain. 1, 2, 3 is another chain. So the rule is for you to take the longest chain as your parent's chain. So in this chain we have 1, 2, 3, 4, 5. So the 5 carbon chain is the longest chain, and our parent's chain with 5 carbon is what? A pent. So if it is filled with since it's filled with single bond, it's going to be what? A pentane. So that's how to identify your longest chain. Now, 1, 2, 3, 4, 5, 6, 7. 1, 2, 1. Let's look at these chains. We have different chains here. 1, 2, 3, 4, 5. This is one chain. 1, 2, 3, 4, 5. That is another chain. 1, 2, 3, 4, 5. That is another chain. 1, 2, 3, 4, 5, 6, 7, 8. That is another chain. 1, 2, 3, 4. That's another chain. 1, 2, 3, 4, 5, 6, 7. That's another chain. So, which is our longest chain? Now, it's the chain with the highest number of carbons. So, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So, since it has 8 carbons, we're going to call it what? Oct. And since it's single bonds that are here, it's only going to be an octane. So you have to identify your longest chain as what? The root or the parent hydrocarbon. Rule number 2. Rule number 2 is for you to number your parent chain from the side that gives the side chain the smallest possible number. So if I have this 1, 2, 3, 4. 1. Now the rule is to number from the side that give this 1, 2, 3, 4, 1, 2. So anyone can build the chain. From the side that give this side chain the smallest possible number. So if you consider the longest chain as the parent, you know that the parent will always want to keep the child close to itself. So if you consider that as the parent, you consider this as what? As the child. So the child must have the least number. So I can number this from 2 different directions. I can say 1, 2, 3, 4. That's one direction. 1, 2, 3, 4. So from this direction is on carbon 2. From this direction is on carbon 3. So 2 is smaller than 3. So the side that gives you the smallest number is this direction. So this carbon will be on what? Carbon 2. And you have to identify the side chain. And this is what? Methyl. On carbon 2. Now, if we have this 1, 2, 3, 4, 5. 6. Let me use 7. I have 1 side chain here. Another one there. Yeah. Another one there. Okay, let's just do this one first. So, number from the side and give the side chain the smallest possible number. So, we're going to number from, if you number from this side, 1, 2, 3, 4, 5, 6, 7. So, this is going to be on carbon 5, 4, 3, 2, 1, 6, 7. 1, 2, 3, 4, 5, 6, 7. Why this is a methyl? This is what? An ethyl. Now, the direction that gives us the least number is this direction because 2 is smaller than what? 5. So it's going to be carbon, this is on carbon 2, while this is on carbon 3. Now, when you identify this, you name it alongside your longest chain. Now, what is our longest chain? 1, 2, 3, 4, 5, 6, 7. So our longest chain is what? Heptane. Heptane. So we're going to say now, you have on a heptane ring, or on this parent ring, it has this child, ethyl and what? Methyl. So you said one of the child is what? 3 ethyl. Another child is 2 methyl. And the parent name is what? Heptane. So this rule is actually third rule. So I'll explain in the next rule that we're going to go into. Rule number 3 is for you to name the substituents alphabetically. So when you have 1, 2, or 3 or more substituents, you have to name them what? Alphabetically. So when I have a substituent like so in naming this compound, let me have 1, 1, 2. So let's look for the longest chain first. 1, 2, 3, 4, 5, 6. 6 carbon. 1, 2, 3, 4, 5, 6, 7. 7 carbon. 1, 2, 3, 4, 5, 6. So a 7 carbon should be the longest chain. So 7 is hept. And because hept is a only single bond in the compound, is going to be heptene. Now, this is a methyl, one of the child of this compound. This is a methyl. We'll call them branch chains. Actually, professionally, is branch chain. And then this methyl. This is also a methyl. This will not explain what I want actually, but let's name it. So, in naming this now, we're going to say number from the side that give the side chain the smallest possible number. So let's number from this direction. 1, 2, 3, 4, 5, 6, 7. From this side, the first side chain is on carbon number 3. Why? We number from this side 1, 2, 3, 4, 5, 6. Now, I will not go to the second rule because from any side, the rule that I want to explain still says the same thing, so you will not understand it. So we'll number from any side. The first side chain is on carbon 3, the second is on carbon 4. Any direction is correct. So now we're going to say 3, 4, 5. So we're going to say 3, 4, 4. Because there are 3 methyl now, use the word tri methyl heptane. Trimethyl heptane. Now, the rule I want us to really apply is the example we want to look at. Alright. The rule that says you name the substituent alphabetically. This is how you apply. Now, let's first of all number from the side and give the side chain the smallest possible numbers. We have this side chain, we have this, we have this. Now, the longest chain is this 1, 2, 3, 4, 5, 6, 7. So this is going to be a heptane. Now, this side chain is methyl. Remember, the chloro will be treated as a side chain, an alkyl substituent. Chloro. Now, this one is ethyl. Now, number from the side, I give the branch chain the smallest possible number. We have 1, 2, 3, 4, 5. Am I correct? I've jumped one. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So from this side, the first side chain is of carbon 3. From this side is of carbon 3. Let me do it the way you understand. Let the chloro come here. So this is going to be our chloro. So that will be very clear. So now from this side, this is on carbon 3. While on this side, the first side chain is on carbon number 4. So we're going to name from the side and give the side chain the smallest possible number. Now, but remember you are going to name them alphabetically. We have a methyl, we have a chloro, and an ethyl. C comes before E, and E comes before N. So that's how to name alphabetically. So I'll first of all name the C first. So this is going to be 4 chloro, followed by E, 4 ethyl, followed by what? Methyl, 3 methyl heptane. So that is how to name substituents alphabetically. All right. Rule number 4. When you have substituent group and they exist on the same number, you have to consider the number of the second substituent. The second substituent, you have to consider it. If it is which one gives you the smallest number, it is what you would take. For instance, if I number from here, I have 1, 2, 3, 4, 5, 6, 7. Number from this side, you have 1, 2, 3, 4, 5, 6, 7. So now, all right. Now, so when the first one, when the two first substituent have the same number, you have to consider the second substituent, the direction that gives the smallest number. Now, from this side now, this is on carbon number 2. This is one substituent. On this side, this one too is on carbon number 2. So you leave the first one, you consider the second one. Now, from this side, the second is on carbon on number 3. While from this side, the second is on carbon number 4. So we're going to number from what? We're going to name from this side. Now remember, this is a methyl. This is ethyl. This is a methyl. This is a methyl. We're going to name alphabetically too. So E comes before M. And my E is on carbon number what? 3. So it's going to be 3 ethyl. My first methyl is on carbon number 2. So it's going to be 2, comma. Second ethyl is on carbon number 4. 4. And the third one is on carbon number 6. Remember, it's this direction of numbering that we're using. Comma, 6. Try, because there are 3 methyl, you use the word try. Try. Methyl. Now, our longest chain, 1, 2, 3, 4, 5, 6, 7. Heptane. So that is how to name a compound like this. Let's look at one more example. All right, now, I want you to pause this video and name this compound. Meanwhile, if it's your first time on this channel, do not forget to subscribe, hit the like button and the notification bell so that you get new update as soon as we post them. And if you have any question, leave it in the comment section. I will definitely attend to them. Your contribution are also welcome in the comment section. All right. Now, how do we name this compound? First, we number this chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, which direction give our side chain the smallest? From this side, the first is on carbon 4, while from this side is on carbon 2. So we're going to use number 2. So from this side, we're going to, this is going to be a methyl, a chloro, a bromo, an iodo, and then this is an ethyl. So we'll name alphabetically. So if I'm naming from this direction, if this is the correct direction, it means this one do no longer exist. You get them off. And all these numbers should have to be in your head. This is just for understanding sake. So our bromo is on carbon 4. B comes before every other substituent there. So it's going to be 4 bromo, followed by C, which is on carbon 3. 3 chloro, followed by E, that is on carbon 3 too. 3 ethyl, followed by I, that is on carbon 2. 2 iodo, followed by the methyl group on carbon 2. 2 methyl. Now let's look at 1, 2, 3, 4, 5, 6. Our parent chain is a hexane. So the name is 4 bromo, 3 chloro, 3 ethyl, 2 iodo, 2 methyl hexane. So if you have any question you can ask, click the like button and do not forget to subscribe. Thank you.